Welcome students. Today we will discuss about first terminal examination for 11 science for the subject physics. Question paper consists of 4 sections: section A, section B, section C and section D. All sections are compulsory for solving question paper. Section A consists of 2 questions. Question 1 is multiple choice question, that is MCQ type question. Each question carries 1 mark. Question 2 is a very short answer type question, that is VSA type questions. Each question carries 1 mark. So, in first terminal examination, section A consists of or carries 14 marks. Similarly, section B consists of 11 questions. These questions are short answer 1 type questions. Each question carries 2 marks. Only 8 questions can be solved from 11 questions. Section B carries 16 marks. So, section A and B, it carries 30 marks for first terminal examination. Section C consists of 6 questions. These questions are short answer second type questions. Any 4 questions from 6 questions are solved. Each question carries 3 marks. Section C carries 12 marks. Section D consists of 4 questions. These questions are long answer type, LA type questions. Each question carries 4 marks. So, any 2 questions from 4 questions are solved in first terminal examination. So, section C and section D total carries 20 marks. In first terminal, we see section A and section B carries 30 marks and section C, section D carries 20 marks. Total 50 marks. In section A, the question number 1, which is select and write the most appropriate answer from the given alternative options of multiple choice question. But general instruction is there. In this MCQ, we can write correct answer along with its alphabet. Like, if answer is A, then write option for A. Similarly, B. Similarly, C. But no mark will be given. Only you can write alphabet like A, B, C, D without option. If only correct answer with alphabet, then we can write only in first attempt. So, we can see the first question will be in brackets L raised to 1, M raised to 1, T raised to minus 2 is dimensional formula for. Option is A, velocity, B, acceleration, C, force and D, work. Your correct answer is option C, force, because force equal to product of mass and acceleration, which is equal to mass into velocity upon time is equal to mass upon time multiplied by distance upon time. So mass into distance upon time square. Therefore square bracket L raised to 1 m raised to 1 t raised to minus 2 square bracket complete is a force. Question 2, which of the following is not a fundamental unit? Option A cm, B kg, C centigrade and D volt. The correct answer will be D volt, because volt is SI unit of potential. Electric potential is a ratio of work upon charge. So electric potential is not fundamental quantity. Electric potential is derived quantity. Question 3. For two vectors to be equal, they should have the option A same magnitude, option B same direction, option C same magnitude and direction, option D same magnitude but opposite direction. So answer is option C, same magnitude and direction, because for representing the same physical quantity, so the two vectors are said to be equal, has same magnitude and direction. Question 4. Which of the following is a vector? Option A speed, option B displacement, option C mass, option D time. So answer is displacement, because the quantity like speed, mass, time, these are scalar quantity. They has only magnitude, but the quantity like displacement has magnitude as well as direction. So displacement is a vector quantity. Answer is option B displacement. Question 5. Which of the following produces a uniform electric field? Option A point charge, option B linear charge, option C two parallel plates, option D charges distributed on circular disc. Answer is option C, two parallel plates, because in uniform electric field magnitude and direction is same at all points. In battery, two parallel plates are there. Uniform electric field is formed between the two parallel plates. Question 6. SI unit of electric field is option A Newton per coulomb, option B coulomb per Newton, option C coulomb per meter and option D coulomb per meter square. So answer is option A Newton per coulomb, because by definition of electric field intensity is the force experienced by a charge. So vector E equal to force upon charge. So SI unit is Newton per coulomb. Question 7. When sound waves travels from air medium to water medium, which of these remains constant? Option A velocity, option B frequency, option C wavelength and option D all of these. So answer is option B frequency, because when sound wave or light wave is move or travel from one medium air to another medium denser or water, then velocity and wavelength both are changes but frequency remains constant. So we know that relation velocity equal to frequency into wavelength, so frequency will be constant. Question 2. Answer the following questions. In this question 2, question 1 will be define frequency. Answer is the number of vibration or oscillation performed by particle in 1 second is called frequency of wave, or reciprocal of time period of wave is also called frequency of wave. It is denoted by n in sound waves and it is denoted by nu in light waves. So frequency is equal to 1 upon time period. Its SI unit is second raised to minus 1 or hertz. Question 2. Define amplitude. Answer is amplitude of wave is defined as the maximum or largest distance of a particle of the medium through which wave is propagating from its rest position called amplitude of wave, or amplitude of wave is defined as maximum displacement of a particle of the medium through which the wave is propagating from its mean position. Question 3. State the law of conservation of charge. Answer is conservation of charge means charge is constant. The law of conservation of charge states that in any closed or isolated system, the algebraic sum of all the electric charges is constant. That is, net charge cannot be created nor destroyed. Question number 4 is define unit of charge. Answer is SI unit of charge is coulomb. Is defined as 1 coulomb is the amount of charge which is placed at a distance of same magnitude in air or vacuum which experience a force is 9 into 10 raised to 9 Newton. According to Coulomb's law, F is equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. If R equal to 1, Q1 equal to Q2 equal to Q, then force is equal to 1 upon 4 pi epsilon 0 in bracket 1 into 1 upon 1 square, that is 9 into 10 raised to 9. So force is 9 into 10 raised to 9 Newton. Question number 5 is numerical. In this numerical, half mark for formula and half mark for correct answer. So a force of 60 Newton acting perpendicular to a force of 80 Newton. Calculate magnitude of resultant force. So given two forces, F1 is 60 Newton, F2 is 80 Newton, and we can find out resultant force. For perpendicular, theta is 90 degree. So cos theta becomes 1. Cos theta becomes 0. So resultant force is F equal to square root of F1 square plus F2 square plus 2 F1 F2 into cos theta. Cos theta is 0, so it remains 0. So square root of F1 square plus F2 square. So it is square root of 1000. So it becomes resultant force is 100 Newton. Question 6 is also a numerical. The Earth's radius is 6371 km. what is the order of magnitude of Earth's radius? So here answer will be given radius of Earth is 6371 kilometer, means 6371 into 10 raised to 3 meter, means 6.371 into 10 raised to 3 multiplied by 10 raised to 3 becomes 10 raised to 6. So the order of magnitude of Earth radius is 10 raised to 6 meter, or radius of Earth is 0.6371 into 10 raised to 7. So order of magnitude is 10 raised to 7. Question 7. What are the fundamental units and derived units? So first answer will be fundamental units are defined as the physical quantity having fundamental unit which does not depends on another physical quantity called fundamental unit, or the units which are used for measurement of fundamental quantity called fundamental unit. Example for fundamental units are meter, kilogram, second, ampere, Kelvin, candela, mole are fundamental units. But derived unit will be the units which are used to measure the derived quantity which does not depends on another physical quantity called derived unit. Example will be meter per second cube, kilogram per meter cube, kilogram meter square, kilogram meter per second, kilogram per meter second square are derived units. We see section B. Attempt any 8 of the following question. Each question carry 2 marks. So question number 3. What is the order of magnitude? Explain with 2 examples. Answer will be order of magnitude of a physical quantity is its magnitude expressed to the nearest integral power of 10. Therefore, magnitude of physical quantity can be expressed as A multiplied by 10 raised to n, where A is number such that 0.5 less than or equal to A less than or equal to 5, and n is an integer called as order of magnitude. Example number 1. Universal gravitational constant capital G is equal to 6.67 into 10 raised to minus 11 Newton meter square per kg square. So order of magnitude is 10 raised to minus 11 Newton meter square per kg square, and mass of electron is equal to 9.1 into 10 raised to minus 31 kg. So order of magnitude is 10 raised to minus 31 kg, and charge of electron is 1.6 into 10 raised to minus 19 coulomb. So order of magnitude is 10 raised to minus 19 coulomb. So here examples carries 1 mark and definition carries 1 marks. Question number 4 is numerical. If 3 measurements are 18.425 centimeter and 7.21 centimeter and 5.0 centimeter, write its addition up to proper significant figure. Data. 3 measurements are L1 is equal to 18.425 centimeter, L2 is equal to 7.21 centimeter, L3 equal to 5.0 centimeter. So total length is sum of L1 plus L2 plus L3, which is equal to 18.425 plus 7.21 plus 5.0. their summation is 30.635 centimeter, which will be 3.0635 into 10 raised to 1 centimeter. So total measurement has 5 significant figure. Here half mark for formula, half mark for substitution, 1 mark for correct answer, or half mark for answer and half mark for correct answer. Question number 5. Describe FPS and CGS systems of unit. Answer will be FPS system is British system, in which F stands for foot, P stands for pound, S stands for second, respectively. FPS system is introduced in 1824. In FPS system, foot is used for measurement of length, pound is used for measurement of mass, and second is used for measurement of time. In CGS system is French system, is introduced in 1874. In this system, C stands for centimeter, capital G stands for gram, S stands for second, respectively. In CGS system, centimeter is used for measurement of length, gram is used for measurement of mass, and second is used for measurement of time. Here 1 mark for FPS system and 1 mark for CGS system. Question number 6. What is the difference between scalar and a vector? First column is scalar, second column is vector. In scalar quantity possess only magnitude. In vector quantity possess magnitude as well as direction. Second difference is examples. In scalar quantity, examples are length, mass, time, temperature, density, speed, etc. In vector, examples are displacement, velocity, force, acceleration, momentum. Scalar quantity or scalar obeys ordinary law of algebra, like for addition, for multiplication, for subtraction, etc. Whereas vector quantity or vector does not obey the ordinary law of algebra. Fourth difference will be scalar changes if magnitude is changed. In vector changes if either magnitude or direction or both changes. Each difference get half mark. Question number 7. Define the following term. First, null vector. Second, negative vector. Answer will be null vector is called as zero vector. Null vector is defined as a vector which has zero magnitude with a particular direction or ordinary direction called zero vector. Zero vector is symbolically represented as vector 0. Example for null vector is velocity vector of a stationary particle is null vector. Second, negative vector. Negative vector is also called as opposite vector. It is defined as a vector which has same magnitude but opposite direction is called negative vector. In figure, we have seen vector A is negative vector to vector B, whereas vector B is negative vector to vector A. Each definition carries 1 mark. Question number 8. A force vector F equal to 4 vector I plus 6 vector J plus 3 vector K acting on a particle produces a displacement of vector S is equal to 2 vector I plus 3 vector J plus 5 vector K, where F is expressed in Newton and S is expressed in meter. Find work done by the force. So, answer will be given data. Vector F is equal to 4 vector I plus 6 vector J plus 3 vector K, and vector S is equal to 2 vector I plus 3 vector J plus 5 vector K. Work done is equal to question mark. We know formula for work done, dW equal to force vector F dot vector S. So, in bracket 4 vector I plus 6 vector J plus 3 vector K bracket close dot 2 vector I plus 3 vector J plus 5 vector K. Using formula vector A dot vector B equal to AX BX plus AY BY plus AZ BZ. So, vector F dot vector S is equal to 4 multiplied by 2 plus 6 multiplied by 3 plus 3 multiplied by 5. 8 plus 18 plus 15. So, work done is 41 joule. Here, formula gets half mark, substitution gets half mark, and answer gets 1 mark. Question 9. State any 4 characteristics of electric lines of force. Answer will be following are the characteristics of electric lines of force. Number 1. Electric lines of force starts from a positive charge and end to a negative charge. Second characteristics will be electric lines of force do not cross with each other. Third characteristics will be the region of strong or largest electric field intensity. The lines of force are crowded, whereas in the region of weak or small electric field, lines of force are separated. And the fourth characteristics, in uniform electric field, lines of force are straight line or parallel to each other, are equidistant, but in non-uniform electric field, lines of forces are curved. Each characteristics carry half mark. Question number 10. Numerical. What is the force between two small charge spheres having charges 2 into 10 raised to minus 7 coulomb and 3 into 10 raised to minus 7 coulomb are placed 30 centimeter apart in air? Answer will be given data. Force is question mark. Q1 is equal to 2 into 10 raised to minus 7 coulomb. Q2 equal to 3 into 10 raised to minus 7 coulomb. R is equal to 30 centimeter. 30 into 10 raised to minus 2 meter. For air, K equal to 1. 1 upon 4 pi epsilon 0 is equal to 9 into 10 raised to 9 Newton meter square per coulomb square. We know from Coulomb's law in electrostatics, force is equal to 1 upon 4 pi epsilon 0 K Q1 Q2 upon R square. By substitute the values, so force will be 0.006 Newton. Question number 11, also numerical. A tuning fork of frequency 170 Hz produce a sound wave of wavelength 2 meter. Calculate the speed of sound. Given data, frequency n is equal to 170 Hz, wavelength lambda equal to 2m, and velocity v equal to question mark. Relation between frequency, wavelength and velocity. V equal to n lambda. So V equal to 170 multiplied by 2. So their product is 340 meter per second. Question number 12. Define the following term. A. Velocity. B. Wavelength. So answer is velocity. The distance covered by a wave per unit time is called velocity of wave. In wave covers a distance equal to wavelength during the time period. So velocity of wave is equal to wavelength upon time period. We know another definition, wavelength. The distance between two successive particles which are in the same state of vibration called wavelength. Wavelength is denoted by lambda. It is measured in meter. Each definition carries 1 mark. Question number 13. Define the following term. A. Dipole axis. B. Equatorial line. Answer will be dipole axis. A pair of equal and opposite charges are separated by a finite distance is called electric dipole axis, or the line which join two charges are called dipole axis. Equatorial line. A line passing through the center of dipole and perpendicular to axial line is called equatorial line, or a point which is perpendicular to the center of dipole axis is called equatorial point along the line is also called equatorial line. Each definition carry 1 mark. Section C. Attempt any 4 of the following. So question number 14 is numerical. Is a certain sound wave in air has a speed of 340 meter per second and wavelength 1.7 meter. For this wave, calculate number 1 the frequency, number 2 the period. Given data, V equal to 340 meter per second, lambda equal to 1.7 meter, frequency n equal to question mark, and time period t equal to question mark. We know the relation between velocity, frequency and wavelength. V equal to n lambda. So n equal to V upon lambda, which is 200 Hertz, and frequency equal to formula reciprocal of time period. So time period equal to reciprocal of frequency. It will be 0.5 into 10 raised to minus 2 second, or 5 into 10 raised to minus 3 second, or 5 millisecond. Question number 15. What is meant by phase of wave? Answer is consider propagation of wave which travel along positive direction of x-axis, and the displacement of wave is y is along y-axis of medium from its equilibrium position as shown below. Figure is seen. In this figure, displacement of wave is y, which is equal to a sin omega t. Every particle or successive particle lags a phase behind previous particle. Therefore, y equal to a sin omega t minus delta, where delta is phase difference. Let any point P at distance x from O. As delta is phase difference at distance x and 2 pi is phase difference at distance lambda. Therefore, delta upon 2 pi equal to x upon lambda. So, delta equal to 2 pi x upon lambda. Therefore, delta equal to 2 pi upon lambda bracket close into x, which is equal to kx. So, equation 1 becomes y equal to a sin bracket omega t minus 2 pi x upon lambda bracket close. If phi is initial angle, then y equal to a sin in bracket omega t minus 2 pi x upon lambda plus phi bracket close. Displacement of particle of the medium from equilibrium position y, the coordinate x and t, is equal to a sin in bracket 2 pi x upon lambda plus 2 pi n t plus phi. Here 2 pi x upon lambda plus 2 pi n t plus phi is the phase of particle at time t second. Question number 16. State and explain principle of superposition. Answer is whenever two or more waves arrive at a point at the same time, the resultant displacement at that point at that instant time is vector sum of the displacement due to each wave acts as independently. Consider the two waves traveling in a medium arriving simultaneously at a point P. Let y1 and y2 be the two displacement due to two waves at the point. Then, according to principle of superposition of two waves, resultant displacement is vector y equal to vector y1 plus vector y2. For maximum displacement, vector y equal to mod vector mod y1 plus mod y2, and for minimum displacement, y is equal to mod y1 minus mod y2. So here statement is 1 mark, explanation is 1 mark, maximum displacement half mark and minimum displacement half mark. Question number 17. Numerical. Compare the electrostatics and gravitational forces between two protons which are 10 raised to minus 15 meter apart. Value of capital G is equal to 6.67 into 10 raised to minus 11 meter raised to cube kg raised to minus 1 second raised to minus 2. Given data, ratio Fe upon Fg is equal to question mark. R is 10 raised to minus 15 meter. Mass of each proton will be 1.67 into 10 raised to minus 27 kg. Charge of each proton will be 1.6 into 10 raised to minus 19 coulomb, and 1 upon 4 pi epsilon 0 is equal to 9 into 10 raised to 9 Newton meter square per coulomb square, and capital G is equal to 6.67 into 10 raised to minus 11 meter raised to 3 kg raised to minus 1 and second raised to minus 2. We know the two formulas for electrostatic force. Fe equal to 1 upon 4 pi epsilon 0 into E multiplied by E upon R square. Equation number 1. For gravitational force, Fg equal to capital G mm m p into mp upon R square. By compare the two forces, Fe upon Fg is equal to 1 upon 4 pi epsilon 0 E multiplied by E upon R square divided by capital G multiplied by mp multiplied by mp R square. If we substitute the values, by substituting the values using logarithmic table, by calculation, ratio of electrostatic force upon gravitational force is equal to 1.239 into 10 raised to 36 will be the comparison of two forces between two protons. Question number 18. Find the conversion factor between the SI and CGS unit of work using dimensional analysis. Answer is, first of all, we want to find the dimension of work. So work equal to force multiplied by distance, which is equal to mass multiplied by acceleration multiplied by distance, is equal to mass multiplied by velocity upon time multiplied by distance. So work is equal to mass upon time multiplied by distance upon time multiplied by distance, which is equal to mass into distance square upon time square. So dimension of work is square bracket L raised to 2 m raised to 1 t raised to minus 2. Let x be the conversion factor between SI unit and CGS unit of work. SI unit of work is joule and CGS unit of work is erg. So therefore 1 joule equal to x erg, square bracket L1 raised to 2 m1 raised to 1 t1 raised to minus 2 square bracket complete SI unit is equal to x, square bracket L2 raised to 2 m2 raised to 1 t2 raised to minus 2 square bracket complete CGS unit, and therefore x is equal to square bracket L1 raised to 2 m1 raised to 1 and t1 raised to minus 2 square bracket complete SI unit divided by square bracket L2 raised to 2 m2 raised to 1 and t2 raised to minus 2 square bracket complete. So square bracket L1 upon L2 bracket square multiplied by m1 upon m2 bracket multiplied by t1 upon t2 bracket raised to minus 2. Here meter upon centimeter to the power 2 multiplied by kilogram upon gram power 1 multiplied by second upon second its power minus 2. First second get cancel. So meter upon centimeter square multiplied by kilogram upon gram. We know that 1 meter is 100 centimeter. So 100 centimeter upon centimeter power 2 multiplied by 1000 gram upon gram. Gram get cancel, centimeter get cancel. So 100 power 2 multiplied by 1000. Here 10 raised to 7. So x is equal to 10 raised to 7. Therefore 1 joule equal to 10 raised to 7 erg. So conversion factor between SI and CGS unit of work is 10 raised to 7. Question number 19. Prove that association property of vector addition. Its answer will be, consider two vectors, vector A and vector B, and another two vectors, vector C and vector D, are joined as shown in figure. Join the two diagonal MO and PN, means it forms PMNO. So join MO and PN. Let vector R is resultant vector for the addition of two vectors. In triangle PMN, vector A plus vector B equal to vector R. Suppose this is equation number 1. In another triangle MNO, vector B plus vector C is equal to vector R. Here let vector D is the fourth vector which is also resultant of addition of vector A, vector B and vector C. Here in triangle PNO, vector R plus vector C equal to vector D. From equation 1 and 2, above equation becomes in bracket vector A plus vector B bracket close plus vector C is equal to vector D. That is equation number B. In triangle PMO, from figure we see that vector A plus vector R is equal to vector D. From equation 2, the above equation becomes vector A plus in bracket vector B plus vector C bracket close equal to vector D. Equation C. If we see equation B and C, so we say that bracket vector A plus vector B bracket close plus vector C is equal to vector A plus in bracket vector B plus vector C, which proves associative law or association property of vector addition. We have seen section D. Attempt any two of the following question. So question number 20. Explain permittivity, and a numerical is given. Two small sphere 18 cm apart have equal negative charge and repulsive force between two sphere is 6 into 10 raised to minus 8 Newton. Find total charge on the sphere. In bracket, the value is given 1 upon 4 pi epsilon 0 equal to 9 into 10 raised to 9 Newton meter square per coulomb square, bracket close. So answer will be, permittivity is a constant of proportionality that relates the electric field having a constant value in air or vacuum is epsilon 0 equal to 8.85 into 10 raised to minus 12 coulomb square per Newton meter square, is also called absolute permittivity. If K is a dielectric constant or relative permittivity, then we say that relative permittivity is ratio of permittivity in medium to the permittivity in free space. Therefore, K equal to epsilon upon epsilon 0. Therefore, epsilon is equal to K epsilon 0. But for air, K equal to 1. So we say that epsilon is epsilon equal to epsilon 0. SI unit of permittivity is coulomb square per Newton meter square. We see dimension of permittivity is epsilon 0 equal to charge bracket square divided by force multiplied by distance bracket square. So epsilon 0 equal to numerator in bracket current multiplied by time bracket square divided by mass multiplied by acceleration multiplied by bracket distance square. If we solving, so here dimension of permittivity in free space or in air is equal to square bracket L raised to minus 3, m raised to minus 1, t raised to 4, I raised to 2, square bracket complete. So, if we solve numerical, so given data will be R is equal to 18 into 10 raised to minus 2 meter. Force is 6 into 10 raised to minus 8 Newton. The two charges are negative, which are equal. So, Q1 equal to Q2 equal to Q. And therefore, total charge Q dash is equal to Q1 plus Q2, which can be calculated. Given the value is 1 upon 4 pi epsilon 0 equal to 9 into 10 raised to 9 Newton meter square per Coulomb square. Using Coulomb's law, we have to write a formula. F is equal to 1 upon 4 pi epsilon 0 Q1 multiplied by Q2 upon R square. If we solve, here we get a formula Q square is equal to F upon in bracket 1 upon 4 pi epsilon 0 multiplied by R square. Substitute the values. So, Q square is equal to 6 multiplied by 10 raised to minus 8 divided by 9 into 10 raised to 9 multiplied by 18 into 10 raised to minus 2 bracket square. By solving, Q square is becomes 21.6 into 10 raised to minus 2 20. So, if we take square root, Q is equal to 4.648 into 10 raised to minus 10 Coulomb. Therefore, charges Q1 and Q2 will be minus 4.648 into 10 raised to minus 10 Coulomb. So, total charge, it will be twice. So, total charge becomes minus 9.296 into 10 raised to minus 10 Coulomb will be the answer for given numerical. We see question number 21. State and prove parallelogram law of vector addition and determine magnitude and direction of resultant vectors. When two vectors are joined at their tail ends to form two adjacent sides of a parallelogram, the diagonal drawn from the tail ends represent the magnitude and direction of resultant of two vectors. Proof. Let vector P and vector Q be the two adjacent or oblique vectors with making an angle theta between them as shown in figure. Side AD represents vector P and side AB represents vector Q. Diagonal AC represents vector R, which is called resultant vector, forming parallelogram ABCD such that side AD equal to side BC equal to vector P and side AB equal to side CD is equal to vector Q. Using law of addition of two vector by triangle method, side AC, which is equal to vector R, is equal to vector side AD plus side AB, means vector R is equal to vector P plus vector Q. Draw a perpendicular from C on AD at M forms a right angled triangle DMC. In this triangle, therefore, CD square is equal to CM square plus DM square, equation A. In right angle triangle AMC, AC square equal to CM square plus AM square, but AM equal to AD plus DM. Therefore, AC square is equal to CM square plus in bracket AD plus DM bracket square. If we solving, so here we can see AC square equal to CD square plus AD square plus 2AD into DM. Here we can see the two values in triangle DMC. Here if theta is angle, so sin theta equal to Cm upon CD, so Cm is equal to CD sin theta, and dm is equal to, or cos theta equal to dm upon cd, so dm equal to cd cos theta. Therefore Cm equal to vector q sin theta and dm equal to vector q cos theta. So above equation becomes AC. Put the value of dm which is equal to vector q cos theta. So AC square equal to CD square plus AD square plus 2AD into vector q cos theta. By substituting the values, so vector r square is equal to vector q square plus vector p square plus vector plus 2 vector p dot vector q cos theta. Taking square root, so vector r is equal to square root of vector p square plus vector q square plus 2 vector p dot vector q cos theta. Hence magnitude of resultant vector will be r is equal to square root of p square plus q square plus 2 pq cos theta. For finding direction of resultant vector, let alpha is direction. From figure, in triangle AMC, tan alpha equal to Cm upon AM. Here AM is sum of AD plus DM, whereas AD, which is approximately equal to BC, is vector P, and AB, which is approximately equal to CD, which is vector Q. In triangle DMC, cos theta is equal to dm upon cd, so dm equal to vector q cos theta, whereas sin theta equal to cm upon cd, so cm equal to vector q sin theta. If we substitute, so tan alpha equal to vector q sin theta upon vector p plus vector q cos theta. Therefore we can say tan alpha equal to q sin theta upon p plus q cos theta. Therefore alpha equal to tan inverse in bracket q sin theta upon p plus q cos theta, which is the expression for direction of resultant vector. We see question number 22. What is the personal error and a random error? And a numerical, some amount of current in measurement of by two different ammeter such that I1 equal to 10.04 ampere and I2 equal to 9.88 ampere. Calculate absolute error and relative error in the measurement. Answer will be, first of all we seen personal error. It is the error which are introduced due to fault of observer carelessness in taking observation, etc. Example, while measuring the length of an object with ruler, it is necessary to look at the ruler form directly above. If observer looks it from an angle, then the measured length will be wrong due to parallax. Another error can be seen is random error. It is the error which are introduced even after the following all the procedures to minimize systematic error, which are not determined by chance but are introduced by an inaccuracy. Such type of error may be positive or may be negative. Such type of error cannot eliminated completely, but we can minimize them by repeated observation, taking their average or mean value. Random error occur due to variation in conditions in which experiment is performed. Example: temperature may be changed during the course of experiment, or pressure of gas which is used in experiment may change, or voltage of power supply may change randomly. So we can see the numerical. Given data, current I1 10.04 ampere, current I2 9.98 ampere, we can find out absolute error question mark as well as relative error question mark. First, we know that mean or average value of current is equal to I1 plus I2 upon 2. Substituting the values, you get answer 10.01 ampere is the mean value of current. Absolute error will be mean value of current minus given current. So I mean minus I1 and I mean minus I2. So delta I1, that is absolute error, will be 0.03 ampere. Delta I2 will be I mean minus I2 gives 0.03 ampere. So mean absolute error is delta I1 plus delta I2 upon 2. Mean absolute error will be 0.03 ampere. We want to find relative error. Relative error is the ratio of mean absolute error to or divided by mean current. Mean absolute error will be 0.03 divided by 10.01. Using logarithmic table, we can solve. So relative error, it will be 2.497 into 10 raised to minus 3. Relative error is the ratio, so it has no unit. That will be the answer for given example. We see question number 23. Derive the relation between velocity, wavelength and frequency of wave. And a numerical is given, that is sound wave A has period 0.015 second. Sound wave B has period 0.025 second. Which sound wave has greater frequency? So here, for solving such question, first we will see relation. Consider the progressive wave or the progressive wave when travel through a medium, then wave covered by a distance called wavelength, that is lambda. In periodic time capital T, second, by definition frequency of wave n is equal to 1 upon t. If v is speed of wave, then velocity or speed is equal to distance covered by wave upon time period. V equal to lambda upon capital T. So therefore from equation A, V becomes n lambda, which is the relationship between velocity and frequency and wavelength. We want to solve the example. So given data, for A, time period is 0.015 second. For B, time period is 0.025 second. We want to find which sound wave has great or larger frequency. Time period A is less than time period B. But we know that frequency is reciprocal of time period. So frequency equal to 1 upon capital T. So therefore frequency for A is equal to 1 upon time period A and frequency of B equal to 1 upon time period B. Therefore frequency for A equal to 1 upon 0.015 and frequency for B equal to 1 upon 0.025. By solving them, by taking reciprocal, so frequency for A, it becomes 66.67 Hz, whereas frequency for B is 40 Hz. From this we say that 66.67 Hz is greater or is more. So NA is greater than, or frequency for A is greater than frequency for B. So sound wave A has greater frequency than sound wave B. This will be the answer for given example.